If alignments will be defined using ASC, we recommend using the site layout as a control drawing. Keep in mind that use of ASC civil alignments is not required to use the remainder of the application. If you choose to use LDD or Civil 3D alignments instead, ASC Civil will automatically detect them, read their properties, and acquire any requested data from them, just as if they were created by ASC. You can also take advantage of the easy, fast creation and editing methods ASC Civil uses for alignment definitions, then click a button to upload them into the LDD or Civil 3D database afterwards if you like. There are two ways to define alignments in the ASC, either automatically or manually. If you choose to use the automatic option, you will have to specify which layers ASC should use for those centerline definitions. Also keep in mind that ASC only needs centerline definitions and not offsets. The base map control completely handles the offset alignments. To specify the layers, go to Road Alignments, Preferences, Control Layers. Select the layers that will be used for centerline definition and move them to the right side window and click OK. Now you're ready to define alignments automatically. So go to Road Alignments, Definition, click Automatic, and the alignments are defined. Depending on your site geometry and how the line work was actually laid out, there may be problems creating automatic definitions. For example, I'll import the entities for the alignment that we intended to go completely around the site by going to Road Alignments, Entities, Import Selected, and I'll pick a point near that center line. The alignment definition stopped at one end because the geometry is broken. So in this case, we'll have to undefine all of the alignments along that centerline path and define them manually. So we'll go to Road Alignments, Delete, and we'll pick a point near this center line. I'll hit Return, delete this alignment definition, and then this one. Now we'll go to Road Alignments, Definition, Manual, and we'll explicitly select all the centerline geometry. Press Return, and we've created one continuous alignment. We can verify by importing the entities. To view all of the alignment geometry on the site, click Road Alignments, Entities, and Import All. By default, ASC assigns numerical names to each alignment definition. To change this, go to Road Alignments, Modify Properties, and select a point near the alignment. And change the name to whatever it needs to be. And click OK. This particular alignment should actually start at station 163486. So again, we'll go to Road Alignments, Modify Properties, select a point near the alignment, and change the starting station. And press Return. The end station is automatically recalculated. To properly model commercial type parking spaces on a residential corridor, that area will need to have its own alignment defined. First, we'll need to modify the properties for alignment definition so that we can create broken alignment definitions with 90-degree angles. So we'll go to Road Alignments, Preferences, for Definition. The starting station value is irrelevant because this won't be profiled. However, we do need to turn down the terminal extension length and make it some small value to avoid interference with other alignments and line work. We'll change the minimum route length to a small value as well. And we'll increase the angle tolerance to the maximum value. And click OK. Now for this special case, we'll need to trace a polyline along the back of curb line of the commercial type parking stall area. I'll use layer 0 for this purpose, and I'll draw a polyline. starting at any convenient location. After we've finished tracing the polyline through the back of curb, we'll need to offset the polyline towards the asphalt side. There's no set distance that needs to be used, but 2 or 3 feet is usually sufficient. Once we've created the offset, we can erase the original. Now we'll need to explode the offset polyline. This will be used for an alignment definition. After exploding the offset polyline, we'll need to fillet the 90-degree angles with some small radius. After the filleting is complete, we can now define the alignment. I'll isolate the layer to make selection easy. Now I'll go to Road Alignments, Definition, Manual, and select all the objects by window. The alignment's now defined in the parking areas. After the alignments are created, renamed, and modified as needed, we're ready to begin the vertical process and continue with the rest of the project. The actual alignments are stored in the drawing that was used to create them. However, anytime a change is made to an alignment or a new alignment is defined, that information is exported from the drawing to the ASC data folder into a file called alignments.txt. This is the file that the rest of the project shares and references when they're doing anything that requires alignment information. Any changes to alignments in the site plan will be updated to the alignments.txt file. When we defined the alignments in the site plan, they were stationed for it so we could see where the alignments are and how they were created. If we don't need to see the stations in this drawing, we can simply go to ASC, Road Alignments, Stations, and remove all. Any alignment can be stationed in any drawing in the project. It doesn't have to be stationed in the site plan itself.